welcome to True Projects. In this video, we are going to discuss about the project which is diabetic retinopathy classification using deep learning and transfer learning models. So before getting into the execution, let us understand what is the project about. So what is diabetic retinopathy? It is a complication that affects in the eyes of the people who have diabetes. It is just like the camera of the eye getting broken because of diabetes. So how do this diabetic retinopathy occurs? When a person's high levels of sugar in the blood damages the tiny blood vessels in the retina. Retina is the part of the eye that senses light. So over time, this damage can cause vision problems and even blindness. So why do this diabetic retinopathy matters? If a diabetic patient, if he gets diabetic retinopathy, it will not show any sign in the beginning. So it is hard to know whether it is there or not. So that is why doctors need special tools to look deep into the eye to check for it. Now think about how many people around the world have diabetes. With more people getting diabetes, the chances of someone developing retinopathy also increases. And it is becoming a bigger problem because it can lead to vision loss. So it is very important for early diagnosis and treatment. So that is why in this project, we are going to develop an efficient system that will accurately classify various stages of diabetic retinopathy by using deep learning methods and transfer learning methods. So this project is all about doing a comparative study of various deep learning models and transfer learning models for classifying diabetic retinopathy. So initially, we explore various data sets that are APTO, Messidor, RFMD, which contain retinal images. And these images will be pre-processed using the techniques called rescaling, shearing, and flipping to enhance their image quality and prepare them for analysis. So after pre-processing, we build various deep learning and transfer learning models and train them on these data sets. And the models are ResNet, CNN, AlexNet, Exception, and others. So after building and training these algorithms, one of the best performing algorithm will be selected. So how will we select the best performing algorithm? We will use some metrics that are performance evaluation metrics called accuracy, precision, recall, and F1 score. So after evaluating all these algorithms on these metrics, we will select the best performing algorithm. And that is exception, which demonstrated a superior performance. So we have used it for deploying the project. Furthermore, we need software and hardware requirements to implement the project. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Moving on to the hardware requirements, we need operating system of Windows, i5 and above processor, 8 GB and above RAM, 25 GB and above hard disk. Moving forward to algorithms used, these are the algorithms which are built in the project. And we have compared all these algorithms. After comparing, exception has performed well in classifying diabetic retinopathy disease. So what is this exception? Exception is a deep learning technique and it is known for being good at understanding images. It does this by breaking down the process of looking at images into two main steps. First is to look at different parts of the image separately. This is called depth-wise convolution. Then it combines these parts to understand how they relate to each other. This is called point-wise convolution. This helps exception to understand images better and pick up on important details. One of its strengths is that it's really efficient at doing this, which is important when you're dealing with lots of images like in medical analysis. Plus, it's great at figuring out what features in the images are important for making classifications. Another important thing is about exception is that it can learn from other datasets before being used for a specific task. That is transfer learning. This makes it super adaptable and useful for the projects like detecting and classifying stages of diabetic retinopathy. So now we will execute the project. To execute it, first we have to open the code folder which contains source code files. So this is the code folder of the project in which we have source code files. So now let's understand each file, how will it be used in the project. So the first three folders are the dataset folders in which we have retinal images, but they are named differently. So coming to the first folder, which is APTO. This dataset is Asia Pacific Teleophthalmology Society 2019's blindness detection dataset containing 3,662 samples collected from many participants of rural India. So I'm opening this folder. Here we have two subfolders, one is train and the other one is test. So in the train folder, we have five different classes of retinal images. So in the first folder, we have mild diabetic retinopathy images. So here we can see mild diabetic retinopathy images. We'll get back. In this, we have moderate diabetic retinopathy images. Get back. Here we have no diabetic retinopathy images of retina. Get back. Here we have proliferated retinal images of diabetic retinopathy. In the last folder, we have severe diabetic retinopathy retinal images. We use all of these five different classes retinal images to train all the algorithms built in the project. Get back. Similarly, we have in test folder also. So why here are train and test? We use train for training all the algorithms and test for evaluating the algorithms. So get back. Coming to the next dataset folder, which is Mesidor. This Mesidor dataset contains retinal images from diabetic patients captured using fundus photography. These images are annotated with ground truth labels indicating the presence and severity of diabetic retinopathy along with other clinical information. So in this folder, we have six folders. The first five are of retinal images and the last one is output folder. So in the first class, that is 0, it refers to mild diabetic retinopathy. So here we have retinal images of mild diabetic retinopathy. Get back. 1 refers to moderate diabetic retinopathy. So here are the images related to moderate diabetic retinopathy retinal images. 2 refers to no diabetic retinopathy. So these are normal retinal images. Get back. In 3, we have proliferated diabetic retinopathy images. And in 4th, we have severe diabetic retinopathy retinal images. This Macedo folder is imported into the Jupyter notebook. After importing, we have split all these images from all the folders into train and validation sets in the ratio of 70:30. These train and validation sets are stored in the output folder. Here we can see train and validation folders are stored in the output folder. Here we can see all the images of all classes. Similarly in validation folder also. Get back. Coming to the next dataset folder, which is RFMID, it is the retinal fundus images for multi-classes classification. This dataset is a collection of retinal fundus images used for classification of multiple retinal diseases, including diabetic retinopathy, and it contains images captured using fundus photography from patients with various retinal conditions and annotated with labels indicating the presence and type of disease. So I'm opening it. Here we have train folder and a test folder. Coming to train folder, we have four different classes of eye diseases. One is cataract. Here we have images of retinal images related to cataract. In this folder, we have diabetic retinopathy disease images. And here we have glaucoma related retinal images. Here we have normal retinal images. Get back. We train all these classes on all the proposed algorithms. So get back. So here also in the test folder, we have all four different classes. Get back. Coming to the sample folder, we have all three dataset folders. One is Apto, Mesidor, and RFMID. Here in Apto, we have all the five classes of Apto dataset. Here we have all the five classes of Mesidor. And here in RFMID, we have all the four classes. So we use all these dataset that is in the sample folder to test the images in the front end to classify diabetic retinopathy images. So get back. So moving on to the next folder, which is static folder. This folder comprises of CSS, JavaScript, and Bootstrap files. These files they are important for project styling and interactivity. This is the templates folder. Here lies all the HTML pages utilized in the project, and they are index.html, about.html. Each HTML file represents a different page of the website, and it provides a structure and layout for displaying content to the users. This is app.py file. This is the Python file which encompasses the front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be presented in HTML templates. These are the model files which contain the algorithm information, and they will be loaded into the project code during runtime. These are the IBYNB files, which are the Jupyter Notebook files, which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the signup.db file. This file is a database file which is used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the command cd followed by the space, we need to paste the copied path and then click on enter. This will change current directory to the code folder's path. Now we need to compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for all syntax errors in the project. After running the Python app.py file, Flash framework follows the application locally at the default address, which is localhost and the port, unless configured differently. So this is the localhost and this is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. Now we need to open the web browser. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser, and this web page is built using Flash framework. So first we need to sign up. So click on sign up link and enter all the registration details if we are signing up newly. I have already registered and I have an account in it, so I will directly sign in. For that, click on click here link and provide username and the password. So I'm giving my username and the password. Now click on login. I have logged in successfully and I'm redirected to prediction page. I already mentioned that we will be doing classification of diabetic retinopathy using three datasets that are APTOS, Messidor, and RFMID. So first we will do classification for APTOS dataset. For that, under classification, click on APTOS. Here we can see a choose file button. We need to click on that for uploading the retinal images. So click on choose file. From the sample folder, as we're going to do classification for the APTOS dataset, so open the APTOS dataset folder. Here we can see there are 5 classes. So first we will do classification from the mild folder images. So I'm going to upload one mild image, mild diabetic retinopathy image. So I've choose the first one. Now click on open. Here image has been loaded. Now click on upload. Here for the uploaded image, it has correctly predicted as mild diabetic retinopathy, which is non-proliferative diabetic retinopathy. It is in the early stage of the disease in which symptoms will be mild or non-existent, which means that it is at the early stage in that symptoms may be visible or not visible. So now we will try uploading some more images of the same data set. Click on try again. Click on choose file. This time we'll be classifying using moderate diabetic retinopathy images. So I'm selecting the first image. Click on open. Image has been loaded. Now upload it. So the second time also it has correctly predicted as moderate non-proliferative diabetic retinopathy. And it is the tiny blood vessels further swell up, blocking blood flow to the retina and preventing proper nourishment. It is at the stage of moderate. So we will try uploading some more images. Click on try again. Click on choose file. This time we'll be uploading no diabetic retinopathy image. So I'm selecting the third image, click on open. Image is loaded, now uploaded. Here we got the prediction as no diabetic retinopathy, which means that there is no diabetic retinopathy in the given retinal image. We'll try uploading some more images for the same dataset. Click on try again. Click on choose file. This time we'll upload the image from proliferated stage. So open the proliferated dataset. I'm selecting this image. Click on open. Image is loaded. Now upload it. So here it has correctly classified as the retinal image that the person's retina is at proliferated stage of diabetic retinopathy. It is advanced stage where abnormal new blood vessels grow on the surface of retina. He is nothing but he's at advanced stage. Now we'll try uploading one more image. Click on try again. Click on choose file. So we'll upload from the severe folder. So I'm going to upload the last image from this folder. Click on open. Image is loaded. Now upload it. Here, based on the provided image, it has predicted as it is at severe stage diabetic retinopathy and it is an eye condition that can cause vision loss and blindness in people who have diabetes. So it is at last stage. Now we will do classification using other data set. For that, under classification, click on Messidor. Here we can see choose file button. We need to click on that for uploading retinal images. So click on choose file. This time we need to upload the images from Messidor folder. So here we can see 5 different classes. So first we'll upload from this folder. I'm going to choose the third image. Click on open. Image is loaded. Now upload it. Here, based on the uploaded image, it is predicted as it is at mild stage of diabetic retinopathy, which is non-proliferated diabetic retinopathy. It is the early stage of disease in which symptoms will be mild or non-existent. Now we'll try uploading some more images from the same data set. Click on choose file. This time we'll upload some other class. So I'm going to upload from the first class folder. So I'm going to upload this image. Click on open. Image is loaded. Now upload it. Here for the uploaded image, that is retinal image, it has predicted as it is at moderate stage, which is non-proliferated diabetic retinopathy. The tiny blood vessels further swell up, blocking blood flow to the retina and prevent proper nourishment. So he's at moderate stage, which means he can take some preventive measures and he can reduce that diabetic retinopathy disease. Now we'll try uploading some more images of same data set. So click on Messidor, click on choose file. This time we'll be uploading image from this folder. So I'm going to upload the last image. Click on open. Image is loaded. Now upload it. Here we can see that there is no diabetic retinopathy detected, which means the person's eye is healthy. Now we'll upload some more images from the same data set. Click on choose file. Now we will upload image from the third class folder. I'm going to upload this image. Click on open. Here we can see that image is loaded. Now upload it. Here for the uploaded image, it has predicted as proliferated diabetic retinopathy. It is at the advanced stage where abnormal new blood vessels grow on the surface of retina, where immediate action has to be taken. Here we got the prediction for the uploaded image as it is at proliferate diabetic retinopathy stage. It is the advanced stage where abnormal new blood vessels grow on the surface of the retina. It is where the immediate action has to be taken. Now we will try uploading some more images of the same data set. So under classification, click on Messidor, click on choose file. So this time we'll be uploading from class 4 folder. So click on this image, click on open and click on upload. Here for the uploaded image, we got the prediction as it is at severe stage of diabetic retinopathy, an eye condition that can cause vision loss and blindness in people who have diabetes. So it is at last stage. Now we will try uploading images for the other data set. So for that, under classification, click on RFMID. Here we can see a choose file. We need to click on that. Now we have to upload from the RFMID dataset folder. So I'm going to upload the cataract retinal image. So I'm going to upload this image. Here for the uploaded image, it has correctly predicted as a cataract. It is a cloudy area in the lens of your eye, the clear part of the eye that helps to focus the light. Now we will upload some more images from the same dataset. So click on choose file. This time we'll be uploading from the other folder. So I'm going to upload from this folder. I'll upload the last image. Here for the uploaded image, it has predicted as diabetic retinopathy caused by damage due to the blood vessels in the tissue at the back of the eye retina. So now we'll try uploading some more images for the same data set. This time we'll be uploading this image. Click on open and now upload it. Here for the uploaded image, it has predicted as glaucoma is characterized by excess or increased pressure inside the eye, which eventually damages the optic nerve. So it is suffering from glaucoma. Now we will try uploading some more images. So under classification, click on RFMID. So this time we'll upload from the last folder. So I'll be uploading this image. Here for the uploaded image, it has predicted as it is normal eye. Now we will see the comparison graphs of the project. So click on graph. As we have built all the models for all the three data sets, here we have for all the three data set graphs. So I'm going to open the graphs of APTOS data set. So here we have loss and accuracy curve of exception. And this is accuracy comparison graph. Here in this graph, x-axis represents accuracy score of each algorithm and this y-axis represents algorithm names. We can observe that exception got the highest accuracy, so it is deployed for the front end. This is precision score comparison graph. This is recall score. This is FN score. This is false positive rate comparison graph. This is false negative rate comparison graph. This graph is for specificity. This is for sensitivity. This is for kappa score. And this is for ROC score. Now we will see the graphs for Messidor dataset. So here also we have loss and accuracy curve of exception. This is accuracy comparison graph. Here for this data set also we can observe exception is performing well, so it got the highest accuracy. This is precision score comparison graph. This is recall score, FN score, FPR, FNR, specificity, sensitivity, kappa score, and ROC. Now we will see graphs for the other data set, which is RFMID. Similar to other data sets, here also we have loss and accuracy curve of exception, accuracy comparison graph. For this dataset also, exception has performed well, so it got the highest accuracy. This is precision score, recall score, FN score, FPR, FNR, specificity comparison graph, sensitivity comparison graph, kappa score, ROC score. Now click on sign out. In this way, just by uploading images that are retinal images to the system, it will classify diabetic retinopathy.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.